Hello students, in previous lecture we have studied about the Oswald's dilution law for weak acid and Oswald dilution law for weak base, and that Oswald dilution law shows the relationship between dissociation constant of acid and degree of dissociation, as well as it shows the relationship between dissociation constant of base, that is Kb, and alpha is the degree of dissociation of that base in aqueous medium. Then see here one more concept which is related with the ionic equilibria. I am going to discussing with you, that is the autoionization of water. See here, the name itself indicates auto means itself, ionization, that means ion formation of water, that means it is a ion formation of water, and here itself means that is the water molecule itself ionizes to water molecule. That means see here, for example, water molecule which contains ions, that is H plus and OH minus ions, but these ions in pure water it remains undissociated. That means here dissociation of pure water does not takes place. In acidic medium, that means when we add few drops of acid into the water, then water ionizes into H plus ion and OH minus ion. That means water molecule undergoes dissociation in acidic, or when base is also added into it, that means basic water and acidic water undergoes dissociation, and that means ionization of water takes place in acidic medium or in basic medium. But pure water, ionization of water takes place at very small extent. That means very less amount of water undergoes dissociation into H plus and OH minus ion. That means pure water, it acts as a weak electrolyte. All of you studied about that. Weak electrolyte dissociate feebly, that means in very small extent. Out of moles of the weak electrolyte, very few moles, in fraction of moles, undergoes dissociation. That means here pure water is also act as a weak electrolyte. Therefore very few moles of water undergoes dissociation into H plus and OH minus ion. But all of you aware of that H plus ion does not remains free in the solution in water. That means that H plus ion readily combines with another water molecule to gives H3O plus ion. That means together these two reactions or ionic equilibria, we can write, instead of these two equilibrium equation, we can write HOH plus water molecule. There are two water molecules. That means here this water molecule when dissociate into H plus and OH minus ion, then that H plus ion reacts with this water molecule to gives hydronium ion, that is H3O plus OH minus ion. That means pure water undergoes dissociation to gives H plus ion, or it is H3O plus ion and OH minus ions. Then here ionic equilibria is attained between unionized water molecules and ions which is formed dissociated ions, that is hydronium ion and OH minus ion. Between these ionic equilibria is attained in this chemical equation or in water, as it is a weak electrolyte. And all of you aware of that or studied about that, we can apply law of mass action to only weak electrolyte in their aqueous medium. As water is act as a weak electrolyte, that is pure water act as a weak electrolyte, and it gives very less amount of hydronium ion and OH minus ion. Therefore, equilibrium is attained between these dissociated ions and unionized water molecule, and therefore we can apply law of mass action. Applying the law of mass action to this chemical equilibria or to this ionic equilibrium, and then we get the new dissociation constant. That is, see here, first of all we have to apply the law of mass action to this equation. Then K, that is equilibrium constant, is equals to concentration of H3O plus into concentration of OH minus ions, because these two ions are in here product and the reactant molecules, that is water. Therefore concentration of H2O into concentration of H2O. That means we can rearrange this equation, that is K is equals to concentration of H3O plus into concentration of OH minus ion upon concentration of H2 raised to 2. That means, see here, one more concept you have to remind, that here water molecules are in excess amount. That is, here water is in excess amount, and the substance which is in excess amount, the molar concentration of excess substance is always remains constant. It is also constant. That means here molar concentration of H2O raised to 2, that is, it is also constant, which is denoted by K dash. Therefore the equation becomes K is equals to concentration of H3O plus into concentration of OH minus ion upon K dash. Then K dash rearranging, we get K into K dash is equals to concentration of H3O plus into concentration of OH minus ion. Then K into K dash, that is product of two constant, is the new constant which is developed here, that is Kw. Here Kw means it is a dissociation of water molecule, that is, therefore it is Kw means dissociation constant of water, or it is also known as ionic product of water. Therefore, Kw is equals to concentration of H3O plus into concentration of OH minus. Then that is the equation, mathematical equation for ionic product of water. That ionic product of water, we have to define that. I am going to define the ionic product of water. What is ionic product of water, or what is dissociation constant of water? It is nothing but it is a product, that is multiplication. It is a product of molar concentrations of hydronium ion and molar concentration of OH minus ion at given temperature in pure water is called as ionic product of water. Once again, I am repeating the definition from the given mathematical equation. That mathematical equation, when described in words, then that is the definition of ionic product of water. Then see here, what is ionic product of water? Ionic product of water is the product means multiplication. It is a product of molar concentration of hydronium ion and molar concentration of OH minus ion at equilibrium, when at the condition is at equilibrium and in pure water at given temperature. Then see here that ionic product of water, we can calculate it using this formula. Then see here, all of you have studied about that. Pure water, that is pure water is act as a weak electrolyte and it dissociates feebly. That means in very less extent, dissociation of that weak electrolyte, that is water, takes place at room temperature. That means at room temperature, and room temperature is considered, that is at 298 Kelvin. Pure water, for pure water, Kw is equals to concentration of H3O plus into concentration of OH minus. And here the molar concentration term, which is measured in mole per dm3. Mole per dm3 is the unit of to measure the molar concentration, or it is mole per liter. That means molar concentration of any electrolyte, any substance in aqueous medium, it can be calculated in mole per dm3 or in mole per liter. That is SI unit of molar concentration of any substance is mole per dm3 or mole per liter. Then see here, pure water at room temperature, that is at 298 Kelvin, it dissociates and gives hydronium ion and hydroxyl ion, OH minus ion. And at room temperature, the H plus ion and OH minus ion in pure water is always having equal concentration. That means molar concentration of H plus ion and OH minus ion in pure water at 298 Kelvin at room temperature, it is always equal. That means we can write the molar concentration of H3O plus, that is hydronium ion, is equals to molar concentration of hydroxyl ion in pure water at room temperature. Condition should be required here, that is at room temperature and pure water should be there. Then the concentration, that is molar concentration of H plus ion and OH minus ion are always equal, and it is nearly equals to, that is H plus ion concentration is also 1 into 10 raised to minus 7, as well as molar concentration of OH minus ion is also equals to 1.0 into 10 raised to minus 7. That means, see here, the putting these value of in this equation, we get the value of Kw, that is here Kw is equals to concentration of H plus into concentration of OH minus ion. That means it is a concentration of hydronium ion into concentration of OH minus ion. Therefore, Kw is equals to 1 into 10 raised to minus 7 into 1 into 10 raised to minus 7. Therefore, the value of Kw, that is ionic product of water at room temperature for pure water, it is 1 into 10 raised to minus 14. You have to remind this value, that is ionic product of water at room temperature for pure water, it is 1 into 10 raised to minus 14. Then see here the H plus ion concentration which is present in the any aqueous solution of any substance, whether that is acid or base or it may be salt. Then we can calculate, we can determine the H plus ion concentration of the substance in aqueous medium, and that H plus ion concentration which is measured in mole per liter, or it is measured in mole per dm cube. Then it is convenient to measure the H plus ion concentration in mole per dm cube of any substance in its aqueous medium. It is convenient to express the H plus ion concentration in logarithm form, in logarithmic form. That means we can calculate or we can express the concentration, that is molar concentration of H plus ion in mole per dm cube. It is also expressed in logarithmic scale which is called as pH of the substance. Then what is pH? The pH scale you have studied about that in 9th standard as well as in 10th standard. Then that means we can express the H plus ion concentration in terms of logarithmic scale, that is in the terms of pH. Then about pH we will discussing here. The scientist Sorensen, who discovered the pH scale for any substance in its aqueous medium. that means Sorensen scientist, Sorensen, who discovered the new scale of expressing molar concentration of H plus ion of that substance in aqueous medium, that is pH scale. Then all of you studied about the pH scale. When pH of any substance, it is less than 7, then it is acidic. If it is greater than 7, then it is, that substance is basic. And when the pH of substance is exactly 7, then it is neutral. Then see here, Sorensen, who defined or who expressed the term pH, which is expressed in the form of mathematical expression. That means he expressed the pH scale in or pH of any substance mathematically. That means see here, the pH of any substance, that is known as potence of H plus ion concentration. Potence means strength of H plus ion concentration. We can determine the acidity or basicity or neutrality of the substance depending upon the strength of H plus ion concentration present in the aqueous solution of that substance. Then that pH can be calculated mathematically according to Sorensen, that is pH is equals to, it is a negative logarithm of H plus ion concentration to the base 10. All of you have studied about the logarithm in maths. Then see here, it is a mathematical expression of pH. That means we can define pH of the substance using this mathematical expression. Then see here, what is the definition of pH? Then it is a negative logarithm of negative logarithm of H plus ion concentration to the base 10. That is the pH of that substance. Then H plus ion concentration of any substance, that is molar concentration of H plus ion of substance, it is measured in aqueous medium of that substance. That means when the substance dissolved in given amount of water, then any substance, whether that substance is acidic or it may be basic or it may be neutral, then when that substance dissolved in aqueous medium, then that solution which containing H plus ion, and we can count the molar concentration of that H plus ion present in that solution, and from which if we measure the H plus ion concentration in mole per dm cube, then we can find out the pH of that substance. That means pH of the substance depends upon molar concentration of H plus ion present in aqueous medium of that substance. Then all of you studied about that the substance, any substance which is used in everyday life, it may be acidic or basic or it may be neutral. Depending upon the H plus ion concentration in aqueous medium of that substance, we can determine the nature of that substance, whether it is acidic or basic or it may be neutral. Then all of you aware of that the substance which gives H plus ion in aqueous medium is acid according to Arrhenius. According to Arrhenius theory, what is acid? Acid when dissolved in aqueous medium given amount of water. If that substance it gives H plus ion, then it is a acidic. That means the acidic substance which gives H plus ion in aqueous medium, and we can count the H plus ion, that is molar concentration of that H plus ion of that substance, and then we can calculate the pH of that substance. Then the Sorensen scientists developed the scale of H plus ion concentration and pH scale, pH of that substance, which is related with each other. Then see here, when the molar concentration of H plus ion, that is molar concentration of H plus ion is 0, then pH of that substance is also 0. And similarly, the higher concentration of H plus ion, the highest concentration of H plus ion of strong acid, which is 1 into 10 raised to minus 14, and when the H plus ion concentration is 1 into 10 raised to minus 14, then pH of that substance is 14. Similarly, we can calculate the pH scale, or we can calculate the pH of that substance, which should lies from 0 to 14. And here the molar concentration of H plus ion of substance lies between 0 to 1 into 10 raised to minus 14. If it is 10 raised to minus 1, then it is the pH of that substance is 1. If it is 10 raised to minus 2, then the pH of that substance is 2. Similarly, if the H plus ion concentration is 10 raised to minus 7, then pH of that substance is 7. If the H plus ion concentration is 10 raised to minus 13, then pH of that substance is 13. That means the pH scale developed by the Sorensen, that is, that scale lies between 0 to 14. That means here, see here, the pH scale in which pH of that substance, if it is lies between 0 to 7, then that substance is acidic. And if the pH of any substance lies between 7 to 14, then that substance is basic. And if the pH of the substance is exactly 7, then that substance is neutral. That means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is the pH of any substance. We can calculate by using H plus ion concentration of that substance in aqueous medium. Then see here, Similarly, he developed the pOH scale like pH scale. Then we will discussing on pOH scale. See here the substance, whether it is acidic or basic. Then we can calculate we can determine the molar concentration of H plus ion in the aqueous solution of that substance. Similarly, we can calculate or we can determine the molar concentration of OH minus ion in aqueous solution of that substance. Then what is pOH? pOH is also potence of OH minus ion concentration. Similarly, we can express the molar concentration of OH minus ion in logarithmic form, that is pOH. Then what is pOH? pOH, the mathematical expression for pOH is negative. It is a negative logarithm of OH minus ion concentration to the base 10. Then see here, to calculate the pOH of that substance, we have to count or we have to measure the OH minus ion concentration of that substance in aqueous medium in mole per dm cube or in mole per liter. Then definition of pOH, that is pOH of the substance is the negative logarithm of OH minus ion concentration to the base 10. Then the pOH scale is also developed, in which pOH of the substance, it is always lies between 0 to 14. And here the substance which having pOH 0 to 7, these substances are basic in nature. And the pOH of the substance, if it is lies between 7 to 14, then that substance is acidic in nature. And the pOH of the substance, if it is exactly 7, then it is neutral substance. That means pOH scale is the total reverse of the pH scale. That means here, if pOH of the substance is 0, then pH of that substance is 14. And if the pOH of the substance is 14, then pH of that substance is 0. That means, see here, exactly reverse scale of pH is the pOH scale. Then see here, there is one more relationship between pH and pOH. Then we can find out the relationship between pH and pOH by observing the scale of pOH and pH. See here, when pOH of the substance is 1, then pH of the substance is 30. Similarly, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14 is the pOH scale. Then when pOH of the substance is 0, then pH of that substance is 14. The scale of pH is reverse of the pOH, therefore 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. Then see here the relationship between pH and pH of the substance, that is by observing the scale of pH and pH. The substance which having pOH 0, the pH of that same substance is 14, and when pOH of that substance is 5, then pH of that substance is 9, and pOH of the substance is 14, then pH of that substance is 0. By observing this scale, we can comes to the conclusion, that is pH plus pOH is equals to 14, and that is the relationship between pH and pOH of the substance. Then we can derive this equation. Then it is a derivation for pH plus pOH is equals to 14. To derive this relationship of pH and pOH, first of all, let us consider pure water which act as a weak electrolyte at 298 Kelvin. It dissociate, that is H2O, it dissociate to gives H3O plus ion plus OH minus ions, and ionic equilibria is present in dissociated ion and unionized water molecule. Therefore, by applying law of mass action to this chemical equilibrium, we get the dissociation constant or ionic product of water, that is Kw, is equals to concentration of H3O plus into concentration of OH minus. But we know that Kw, that is ionic product of water, at 298 Kelvin for pure water, it is 1 into 10 raised to minus 40. Then let this equation number 1 and this equation number 2. Observing equation number 1 and 2, see here the left hand is same. Therefore, from equation 1 and 2, we get concentration of H3O plus into concentration of OH minus ion is equals to 1 into 10 raised to minus 40. Then see here, if log on both sides is taken, that means taking log on both sides of this equation. See here, concentration of H3O plus into concentration of OH minus ion is equals to 1 into 10 raised to minus 40. Taking log on both sides. The mathematical laws are used here. That is, when log of these expressions are taken. See here, concentration of H3O plus into, there is multiplication of molar concentration of hydronium ion and OH minus ion. Therefore, when logarithm of that is taken, that is log of H3O plus ion to the base 10. Here multiplication is there. Therefore, addition of logs of these molar concentrations of ions should be considered. Therefore, plus log of OH minus ion to the base 10 is equals to log of 1 to the base 10. Here multiplication is there. Therefore, plus log of 10 raised to minus 14, log of 10 raised to minus 14 to the base 10. Then simplify this equation first. Therefore, log of H3O plus, when we doesn't write 10 to the base 10, but it is a base 10 is till there, plus log of OH minus ion to the base 10 is equals to log 1. Log 1 is always 0, plus, see here, log of 10 raised to minus 14. Here minus 14 is at index in the exponent. Therefore, simplifying this, minus 14 log of 10 to the base 10. That means the term which is in exponent in the degree, which is taken here, minus 14 log 10 to the base 10. Therefore, log of H3O plus to the base 10 plus log of OH minus ion to the base 10 is equals to minus 14 into log 10 is 1. Therefore, see here, minus 14 into 1, that is minus 14. Then reversing the sign on both sides. Therefore, we get negative log of H3O plus to the base 10. Here plus sign is used, but the negative sign, which is of this second term, is written in bracket, or total term is written in bracket. Then negative log of OH minus ion concentration is equals to, here negative sign of 14 is there, which is reversed and it becomes 14. But we know that negative log of H3O plus to the base 10 is nothing but it is a pH. It is a pH. This term is pH. And negative log of OH minus ion is nothing but it is a pH. According to the definition of pH or mathematical expression for pH and pH. Then see here, this term is pH plus this term is pH. pH plus pH is equals to 14. That is the relationship between pH and pH. All of you have studied about the pH of the substance, which is used to determine the nature of that substance. And substance, it may be acidic or basic, or it may be neutral, by determining pH of that substance. Then see here, any substance, it is the nature of substance, it may be acidic, basic or neutral. Then the substance is in, the nature of substance is in three form. That is, for acidic substance, for acidic substance, H plus ion concentration, that is molar concentration of H plus ion is always greater than molar concentration of OH minus ion. And here, therefore, H plus ion concentration of acidic substance, for acidic substance, is always greater than 1 into 10 raised to minus 7. Therefore, pH of the acidic substance is always less than the 7. And that means pH of the acidic substance, it is always less than or lies between 0 to 7. Similarly, for basic substance, in aqueous medium, according to Arrhenius theory, the substance which in aqueous medium dissociate to gives OH minus ion. Therefore, the basic substance which gives OH minus ion in aqueous medium, therefore OH minus ion concentration of basic substance is greater than molar concentration of H plus ion in aqueous medium, and therefore OH minus ion concentration of basic substance is always greater than 1 into 10 raised to minus 7. Therefore, pH of that substance is always greater than 7. And third substance, that is neutral substance. Neutral substance. For neutral substance, like pure water at 298 Kelvin, that means at room temperature. Room temperature is always considered about 25 degrees Celsius, that is 298 Kelvin. Therefore, for neutral substance, H plus ion concentration is equals to OH minus ion concentration, and it is always 1 into 10 raised to minus 7. Therefore, pH of neutral substance is exactly 7 or nearly equals to 7. That is about the pH, pOH and nature of the substance. And nature of substance can be determined by knowing the molar concentration of H plus ion or molar concentration of OH minus ion in its aqueous medium. And if we know the pH and pOH of that substance, we can determine the nature of that substance in aqueous medium. That is about the pH, pOH, relationship between pH and pOH, the derivation for relationship between pH and pOH. That is, relationship between pH and pOH is pH plus pOH is equals to 14. That is about the few concept which is related with the substance, aqueous solution of substance, and which is related with ionic equilibria. Thank you.